First of all, let us understand the difference between cross-sectional versus time series. Then we will look at the differences among these three, which is panel longitudinal data. Let me explain cross-sectional data first. Let me bring in the dataset. Suppose you have the data on who are the patients who were tested positive with respect to COVID and who were the people who were tested as negative. So no COVID, patient 1. Patient 2 also does not have COVID. Patient 3 is COVID positive. 4, 5, 6, so on and so forth. Say you have data of 1,000 patients. Usually this variable of interest would be called as output variable. But anyways, that's the data. For each and every customer, you have the information, and the output variable is represented using Y. And you have name, age, gender, number of hospital visits, historical health conditions, so on and so forth. So you have a lot of inputs. Given this data, does it work in this way, wherein if you go and visit a hospital on Monday at 11 a.m., no matter what, the results will say that you will not have COVID, because this is very auspicious time. Monday, 11 a.m., probably that happens to be very auspicious. And that is why probably you are tested negative for COVID. But then if you go to hospital on Tuesday at 9 p.m., this is some kind of unauspicious, time, probably Rahukal, right? And no matter what, if you get yourself tested for COVID, you would be tested as COVID positive, no matter what. Does it work this way? That based on the date and time that you visit a hospital to get yourself tested for COVID, the outputs are determined whether you are COVID positive or negative. Does it work this way? Not at all. It doesn't work this way, friends. Date and time when a specific patient visits hospital will not determine whether you will be tested negative or positive. Given this context, cross-sectional data is that data where date and time is unimportant. Since date and time is unimportant, the sequence in which you arrange the data becomes unimportant. So you need not sort the data in the ascending order. You need not say that, you know what, this patient visited on 1st Jan, this patient on 2nd Jan, 3rd Jan, 4th Jan, 5th Jan, 6th Jan. In this manner, you need not have the data in a sequence. You need not sort the data, because the output on whether you are tested positive or negative does not really depend on what your date and time happens to be. So this kind of data where date and time becomes unimportant, and hence the sequence in which you arrange the data becomes unimportant, is called as cross-sectional data. Then we have time series dataset. When it comes to time series dataset, the date and time and the sequence in which you arrange the data would become extremely important, and you'll have only a single variable in your dataset. For example, say you're looking at number of COVID-19 cases. When you deal with the number of COVID-19 cases, you need to arrange the data in a sequence. Day 1, day 2, day 3, day 4, day 5, day 6. So it has to be arranged in the sequence. And you can arrange the data in a sequence because you have the variable called date and time. So when date and time becomes important, and since you have date and time variable, you can sort the data in a sequence. And hence sequence becomes important. This kind of data set, wherein date and time becomes important and hence the sequence in which you arrange the data becomes important, is called as time series data set. And one more important observation is that when you look at cross-sectional data, typically, you'll have more variables, more features. You'll have more than one feature. But when it comes to time series data set, you would have a single feature, number of cases, single variable. Of course, you'll have date and time, that also is a column, but then number of cases is an important feature. Alongside date and time variable, you would have only a single variable, right? When it comes to time series data sets. Then we have panel data or longitudinal data sets. You pronounce it as longitudinal or longitudinal, doesn't matter. American and British pronunciations. Okay. So in this kind of a data set, this would take the properties of both cross-sectional data sets and time series data set. Panel data or longitudinal data would take the properties of both cross-sectional data sets as well as time series data sets. In cross-sectional data, you have multiple variables. So here also you'll have multiple variables. Of course, this should be Malaysia. Sorry for that. Okay. So you have India, Malaysia, and America. So you have multiple columns. You have the number of COVID-19 cases on Jan 1st, 2nd, 3rd, 4th, 5th, 6th, so on and so forth, across the various countries. So one thing is from cross-sectional data, since cross-sectional data has multiple variables or features. Here also you have multiple variables or features, point number one. Point number two, time series data has a variable called date and time, and the data is sorted in a sequence, and so is panel or longitudinal data. So you take the properties of time series data, and then you have this data set. So panel or longitudinal data includes the properties of both cross-sectional data as well as time series data, and that would be called as panel or longitudinal data.